start. So lesson 9 has, it's kind of like a review grab bag, and they had 4 topics they wanted to review, and these topics were regex, then transfer learning for computer vision, transfer learning for natural language processing, and also they briefly reviewed SVD. And I think we've done all those topics. I think in particular, we did a pretty deep dive into transfer learning for natural language processing in the last lesson, and I ended up editing it a bit since we had the class last week. So if you want to pick up the newer version, it runs all the way through. And I mean, the one I showed in class was pretty much final, except I hadn't run the very last couple of lines. And so I did that, and I pushed it up to the repo. So that's ready to look at. Anyway, that has a pretty comprehensive review of the process of transfer learning and where and how we do it with FastAI. And the process, they call it ULM fit, Universal Language Model Fit. That's what Jeremy and this other fellow published as his PhD thesis a couple of years back, actually about 1.5 years ago now. And that was a huge breakthrough in natural language processing to apply the technique of transfer learning the same way they had done it in computer vision. And what really stands out is that they actually just took the process of transfer learning step by step and showed how in FastAI that gets implemented. And then they showed how step by step you can just basically implement the exact same process into and apply it to natural language processing. That was a really impressive demo for me. And I think that the NLP field has run with that, and they've made tremendous progress since that, since in the past 1.5 years, with bigger and bigger models, and then BERT, and the one that's based on transformers. And then someone just posted a link that came out just this week that Microsoft built a language model based on 17 billion parameters, and they're in the process of releasing it to the wild. It's just really impressive. But I remember that it all started with Jeremy and the fellow he collaborated with. The guy's name I can't remember right now. Maybe somebody can remind me. Who published it?
It's Sebastian Ruder.
Sebastian Ruder, that's right. He published it as his PhD thesis. So there's 2 notebooks that go along with this lesson. One is let's see, review CV transfer learning. I didn't really do anything to this thing. I put my name on it, because I usually end up editing it, but I didn't edit this one. It just goes as is. I ran it all the way through. It basically just, you set the batch size, you import the Oxford IIIT pet data set. It's just so amazing how smooth and slick this process is in FastAI. A lot goes on under the hood here. Then you use a regex expression to pick out the labels that you want. You train the data set, you fit it, and then you end up with 7% error after 4 cycles. Then you save that and you unfreeze. In other words, this one, the way it works, it's all under the hood. It's so slick, so you have to be a little bit curious about how it works. When you do this first run through fit one cycle, it automatically chops off the head of your CNN, of your neural network, and adapts it for the problem that you're working with here. So and it's just training the very last layer. And then so that's stage 1. And then stage 2 is, now we unfreeze all the weights and let it solve for all the weights. So the first step was we just started by unfreezing only the last layer, letting it train those weights. And now we turn it loose and let it train all the weights. And we end up with the thing that stands out to me is that we got 7% error, 7.2% error, let's say, at the end of 4 cycles. But then when we unfreeze, we didn't do a lot better. It's still 7.2, and it's a little bit worse, in fact. But I would imagine if we keep training, it will go down because the validation loss is still going down. Well, actually, but there's a noise in it. So I'd be curious, although I don't have time right now, I'd be curious to train it just for a few more cycles. It only takes 1.5 minutes for each cycle and see where we get with that. But I'll just leave it at that. So that's the blueprint for the process of transfer learning applied to computer vision problem. Then they have a next notebook, which is the same thing. It's the same blueprint, but now applied to the IMDb sentiment classifier problem that we already solved. This is just a review. So, but here it's all in one place. So what I did was I tried this morning to go through this, and I did have to make some edits on this because of this problem with broken process error that I keep encountering because I have a Windows machine. I'm not sure if this is a problem in with other architectures, with Unix architecture. Somebody can tell me if they've seen that. Anyway, so I did try to run this, but I ran into another error, which I couldn't solve. It gives me an attribute error. Let's see. At this, let's see. Let me try to, I'll show you the error because, let's see. I just set the batch size to be smaller because I know that my machine won't take a large batch size like that. So just as protection, I set it to 32. Now okay, so I've saved these two steps. One step is to create the language model based on this data set. And then the second is to build a classifier model based on this data set. And here's sort of my summary of what happens. The following line, that is this line. And all of this stuff, remember, this is my wrapper, because whenever I get broken process pool errors, I have to run it several times until it goes, right? And so this is the wrapper that you see around it. But this is the main line that we're executing here. What we're doing here is we're building a classifier from the language model. So the input is the data underscore LM, which we did here, which we got here. This is another block, a similar block, but it's just to build a language model. And this is the line that's being executed, and the rest of it is the wrapper that keeps trying to execute it until it does so without throwing a broken process error. That can take like 1 or 2 or 3 or maybe even 6 tries. Anyway, so this is the first line, builds a language model. The second line builds a classifier from that language model. Remember, those were the two things we did. Yeah.
Doesn't it have to call text class data bunch rather than text LM data bunch?
Well, that's a very good question, because the first line, that's what it did.
Okay.
And that's what I tried. And then that's a good question, because this leads me into my spiel here. So I tried this line, which is the line originally in the file, and I got this problem because I got this attribute error backwards, it says, on the learning step, which is after you save and load, and this is the learning step.
Okay, never mind. Okay, so yeah, the factory method is actually like giving you some error for
yes. Yes.
Okay. Never mind.
I get it. Okay. When I throw this, well, I'll even show you, because I think it's all set up so I can do it. If I just run this, no, I have to define it.
Ignore my question. So yeah,
okay, no problem, but that's a good question. So what I tried was, I found on the forum that this line, instead of using the text class data bunch, it says try the text LM data bunch instead. And so I did, and it said that solved the problem, but I didn't find that it solved the problem. I found that it didn't solve the problem. So anyway, I'll show you. Let's see if I can.
Yeah, the only alternative here is going straight to the data block API then.
Yeah, I figured, so I didn't have time to sort this out. I'm sure if I spend another half hour or an hour on this, I'll sort it
I'm
out.
sure you
But yeah, so
Okay.
I'm leaving it
Thanks,
at this notebook is broken, and I'll try to fix it during the week and post it. I'll post a working version. But anyway, all it does is it repeats the thing we did last week. It does this transfer learning step on the smaller IMDb data set. And it's nice that it's all in one notebook. It's all in a very compact notebook, so you can see all the steps. So I like this notebook, and I like the one before it too. Because, I mean, just look at how few lines of code that is. I mean, it's just amazing what you've done with these few lines of code. Basically, 2 screens of code, and there you have the whole transfer learning process. Okay, so I thought for lesson 9, we'll do something a little different. Jeremy says that the most important thing from his point of view is the regex. He was talking to the class.
Joseph?
Jeremy actually gave this lecture.
Joseph,
I guess he was a guest lecturer.
I had a small doubt. Yeah, hi Joseph. I had a small doubt. If I could just take 2 minutes of your time.
Yeah, sure.
Could you show the previous notebook again, where you were trying to run the data bunch? I might maybe be able to help on that. Could you just tell the steps again that you were trying to run?
I'm sorry, could you repeat that?
As I was saying, could you tell the steps, the cells that you were trying to run in order? Maybe, you know, I can take a look and maybe see if there might have been a mistake or something.
Well, let me just, maybe I can run it quickly. So let me just run this. So here we're importing the text API. Why is it taking so long? There it goes. Then we get this data, the sample. Remember the smaller version of the IMDb data set. We read the we read the text file, the CSV, the reviews. The next step is we're actually just trying to execute this, but I put a wrapper around it in order to run it until it works without. So the problem, so what we're trying to do here is we're trying to build this language model.
Right. Why don't you use a text LM data bunch over here? Usually that works, like initially for fine tuning.
Oh, maybe okay. So do you think that would work instead of?
Yeah. So basically, from my experience, what I usually do is we try to fine tune the language model. So I use the text LM data bunch to, you know, set the whole language model data bunch up, and then this step.
Okay, so we're going to do text LM. We're going to do text LM data bunch here, right?
Right.
Okay, let's try that. It shouldn't take too long to.
Yeah, sure.
And
so I think I did it wrong. I think you're right. I think that what I have to do here is go back to the data class.
So basically, I think from the steps, from what I've understood is you first initialize the text LM data bunch for the language model learner. And once you've trained your language model learner, you save the encoder, and then you initialize the data classification, the data class data bunch for the classification.
Yeah.
And then you do the classifier model, you initialize that, and then you load the encoder, and then that's basically the whole step.
Yeah. So I think you're right, and I think this is going to fix it. So this is the next step where we're doing the classifier. So I guess the bottom line that you're pointing out is we should keep this instead of changing it. It was not. I applied the fix to the wrong step. So now we're doing what you said, which is applying this fix to the first step, which is what we wanted to do. And we're there. So now we save what we got. We set the batch size. We load what we got back. And now we should try it. And I think it'll work this time. Let's see. Yeah, you did it. Thank you so much.
Yeah, you're welcome. I had a lot of problems with this initially. So
yeah. So let me, thank you for that. I'm going to get rid of that. And put the comments up here. text. Okay, so it is correct. It is a correct fix, and I'm just going to put that note up here. Okay, so now I've incorporated the fix. We have, let's see, I guess we've done, we can do this now. This should go fast. Okay, so we have 28%, 20.5% accuracy on the language model, which sounds really bad, but it's not for language models. Let's see. We can now unfreeze the weight and unfreeze all the weights and retrain for 3 cycles.
And if anybody really thinks IMDb comments are language,
Pardon?
IMDb comments, I can't imagine be considered language of any kind, of any quality.
Oh, yeah. That's right.
It is entered by human, so you should consider this as language.
Yeah.
Not all humans speak right.
I mean, it's still better than Twitter data.
We vote.
Okay, so let's see. So here's okay, so we've improved our language model accuracy from 28.5% to, well, we haven't really improved it. So running, excuse me, running this thing 3 times didn't really improve things. And so 28% isn't that great. So this is what it did. It doesn't pass the human. It doesn't pass the Turing test. I mean, it's.
So how many documents did we just add to the training?
I think we looked at. Let's see. The IMDb database itself is 1 million documents, but the subset that we looked at, the sample, I believe, is 10,000 documents.
Right. So that's probably just maybe that's part of the problem, right? Why we didn't improve it.
Yeah.
Because of proportion.
So,
also, can you just give me a brief explanation of how evaluation is done under these circumstances for a language model like this when you're doing generative language?
Yeah, so you basically just tell it how many words you want it to generate, because that's what a language model does, is it generates the following word. You can just tell it how many words you want it to come up with, and then it will do that the FastAI interface. So let's try this again.
But actually what I was asking is the evaluation, how you get that 0.28.
I think they might, let's see, that's a good question. I don't know the answer to that. We should look that up.
I mean, does anyone on the call have some idea? Just a rough idea, because
I probably would, still continue with my downstream task and then see if it is actually like, if I increase the data set, will it improve the downstream task accuracy? That's what I would approach it.
No, I guess what I would do is I'd give it a few sentences and ask it to predict the next two or three words, and then I know what the rest of the sentence looks like, so I can compare the words that it generated with the actual words and see what that score would be.
Right, but of course they have some sort of, there is a systematic way of judging
sure.
generative models.
We should look that up and talk about it next time.
It seems almost impossible. That's why a low number is probably a good number, right?
Yeah, so basically around 33% is good. It basically means 1 in 3. It's a 1 in 3 chance that you got the right one.
Yeah,
good.
But the
good to know.
newest model from Microsoft got like 66% or something. The one that I mentioned with the 17 billion parameters. So they are getting better. Okay, so I don't want to go through this. It's just another couple of minutes to get to the end. But we're building on top of our language model. We're now building a classifier. We've done this last lesson, so there's no need to do it again. So what I started doing this morning, and I didn't really finish it, so I thought we would just interactively do it in this lesson, is go through the part on the video about that Jeremy does to review regex. So the first thing we can do is just take 20 minutes or so to listen to this video. I've cut out the part of the video that I want, the part where Jeremy talks about regex, and let's all listen to it together. And then let's go at this Austin Public Health Locations database and try to reconstruct what Jeremy did. Okay, my first attempt was to just read the database, and then of course I got the whole pandas data frame and I got all the phone numbers. That's not what Jeremy's trying to do, so this was a false step. And then I went back and said, okay, because this is the goal. We want to start with the raw text and get the phone numbers and pull out the phone numbers in this format. That's what Jeremy's exercise is to do. So I thought we could go and just reconstruct that for ourselves. So then my second attempt was to go get the database and read it in as a single string. And that's what I did here. So now I've got the database as a string, and you can see going through this that every once in a while you'll come across numbers and phone numbers. So what we'd like to do is process this string using a regex expression to extract all the phone numbers and then print them back in the special format that Jeremy suggested here, the format like that. Because you know how phone numbers get entered in all kinds of different formats. So we're going to find them all and spit them out in a list like this. That's the goal of this exercise. And as you can see, I haven't gotten any farther than this. So I thought I would do the rest of it with you. And we'll just listen to this video for 20 minutes, and then we'll come back and try to reconstruct what Jeremy did. What do you think? Okay?
Sure.
Ready? Before we do this, are there any comments? Let me look at the chat. Let's see. Let's see. So somebody have this. Somebody gave this link. I'm not sure. Oh, the schedule. Okay. Yeah, this is the Google Sheet. And we might as well just look at this quickly. So here's the schedule for this class. And it's taking long. And the reason is that I think when Rachel ran the class, she might have done 2 or 3 lessons a week. But we're only doing 1. So I did find that it's easy to cover one of Rachel's videos in a hour-and-a-half class, whereas I found that for Jeremy's videos it sometimes takes 3 or 4 or 5 classes to cover a single video. So we're going through this one for one, and today we're here. And according to the schedule, we should finish on April 25th. So that's that. Okay, back to our lesson. So the next thing to do is ask for comments. Are there any comments that anybody wants to say, or doubts or questions? Or okay, let us then listen. And I'm assuming that you guys are going to be able to hear this when I play it, so let me know if you can't. Okay, I'm hoping my microphone is going to pick it up enough for you to hear it. So let me do that. Okay, it's supposed to be playing now. Let's see.
Versus what you need to know to pass an exam or pass.
Okay, are you hearing it?
So looking through the notebooks you covered so far.
Okay, great. Thank you.
What stands out to me the most is regular expressions. And it also stands out to me that when Rachel asked who feels very comfortable with regular expressions, I was very surprised by how
is that better, Mosh?
hands went up.
I turned it up. Okay.
As a criticism, but just to say, like, I use regular expressions many times every day to do things in my code editor, to gather data, to like everything almost that involves anything involving file names or data gathering or data munging or whatever. Always I use regular expressions. So the fact that a lot of you aren't familiar with it makes me think you're not taking advantage of a tool that's in your toolbox. So I would say of all the things to take away, that would be the one at the top of my list. So I thought I'd give you a quick example of what a workflow might look like involving regular expressions. Most editors support regular expressions deeply. I happen to use an editor called Vim, which I quite like. I think it's particularly good for data science, but these ideas will hold across many editors. And just before the class started, I just downloaded a data set containing some addresses and phone numbers and things. And I thought, like, maybe I'll show you how I go about cleaning up a data set. So this particular data set apparently is Austin public health locations, which I just downloaded from data.gov. And I was thinking, how would I answer the question, what are all of the phone numbers of Austin public health locations? And I need you to provide them to us in a particular format, which is say like digit, 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 space, digit, 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 space, digit, 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 something like that, right? So how would you go about doing that on this data set? This is the kind of thing that's going to come up all the time. So the first thing I would do would be to select all of the rows in this text file that contain a phone number. And so I would tend to be a bit cautious about guessing what a phone number is, but looking through here, it looks like the phone numbers are generally digit dash digit dash digit. So Vim has a really nice way to find lines containing a regular expression, which is G. G stands for grep. Grep is the normal Unix command for finding stuff. And generally the arguments to commands in Vim have slashes around, them. So I'm going to search for phone numbers. All right, so I guess we could say phone numbers is a digit, one or more digits, followed by a hyphen, followed by one or more digits, followed by a hyphen, followed by one or more digits. And one of the things you'll notice is every program, library, programming language has slightly different regular expressions. Vim's particular oddity is that they require backslashes in more places. Most regular expressions don't need a backslash before the plus. Vim does, unless you change preference setting. So this is going to go ahead and find all of the lines that match this regular expression, and then do what? And this is really nice. In Vim, you can then provide another command to run on those. So the command I want to run is delete, which is D, but actually I want to do all of the ones that don't match that. So like many systems, exclamation mark means not, means the opposite. So this is going to delete all the lines that don't match this regular expression. Done. So it's just deleted 67 lines. Maybe it would be helpful actually if I just undo that to do it without the exclamation mark, see what lines is it going to delete, just to double check that this looks reasonable and that I don't have things that look like phone numbers in them. So no, that looks fine. Guess these are ones that don't have phone numbers, right? So part of my workflow is I tend to do a lot of undo, redo as I play around, and Vim U is undo. So I can just hit up arrow to go back to my previous command that I ran, and here I am. So the second thing I'd want to do is find all of the phone numbers. And maybe I would probably do this in one step, but to make it more clear, I'll do it in two. Find all of the phone numbers and just make each line just the phone number. So that would be one way to do that would be a search for a place. So I could go search for digit, and then dash, and then digit, and then dash, and then digits. And then I want to replace it with everything I just found, which is the same as Python \1. In fact, since I didn't put parentheses around it, I can just say ampersand. That means everything I just mentioned. Actually, let's do it with \1. So if you put parentheses, and again with Vim it's a bit weird, you have to backslash the parentheses. So I'm going to capture the whole thing, replace it, align with that. Oh, and then we're also going to need to say search for everything else in the line. So arbitrary text.
Sorry.
And then something that might be a phone number, and then arbitrary text, and replace it with just the contents in the parentheses. Okay, so that's not quite right, as you can see, because it's left me with what looks like partial phone numbers. So one of the nice things about, like one of the things I'm really careful to do in all of my work is to do things like very interactively. So I would much rather work in Vim or a Jupyter Notebook than write a program, because I want to be playing with the data, right? So this is a really nice way to do things. So now I can hit U to undo, and then I can go back and have a look and see why did this fail. And so this is where it's good to start learning some of the details about regular expressions. And one of the things that's useful to learn is the idea of a greedy match. A greedy match is the idea that when you match something with a wildcard like star or plus, it wants to find as many, as big a group as possible. So the reason this didn't work is that dot star, dot means everything, right? And so including digits. So like there's two possible ways to match this. It could either match everything up to the first of these digits and then stop there and then start capturing digits, or it could match everything including the digits, and then it would only need to find one. So strictly speaking, what it did here, which was in the dot star included those first two digits, totally correct, right? I mean, it's what I asked for, but it's not what I wanted. So you can see how valuable it is to do this kind of interactively. I can just hit U to undo and try again. A couple of ways I could fix this. One is in regular expressions, you can ask for a non-greedy match. And the way you do that is you put a question mark after a asterisk or a plus, and that means as few as possible. All right, so this is now a non-greedy match at the star, which means the greedy match will go on my digits. Let's see, which might not be supported by Vim. So one of the tricks here is different systems also support different subsets of functionality. So this question mark's not working. So then I'd go Vim, regex, non-greedy. Let's see. How do I make it? Okay. So I don't, I've not seen this before. What is this one? Not sure. So it says instead of dot star, use this. Apparently this is a non-greedy. Okay. So let's try it. All right. Okay, so that worked. It's not bad. But perhaps the way I would tend to do it in practice would be, instead of a dot, I might say everything except for 0 to 9. So to create a set of possible things, you put them in square brackets. So that means ASDF. And there's a shortcut, which is if you put something hyphen something, that means everything between these two. So these are all the digits or all the letters. And then to mean everything except those in square brackets, you pop a caret symbol. So this would be non-digits, as many as possible. And so this would also fix the problem. except it didn't. Let's see. Okay, so I'm checking. I just searched for that, and that is working. So that's good. Oh, I see the problem. Okay, so again, it's good that we're doing things interactively. My logic's not right. So I can't search for non-digits because there's lots of digits that aren't in phone numbers that aren't going to match. Which reminds me, people, so when I'm running courses, a lot of students tend to hang out with me in the study room and we just work together, and I tend to get a few comments about things people are surprised by when they're working with me. Maybe the main one is, gosh, I'm surprised how many mistakes you make, except generally phrased slightly more politely. There's plenty of seats over here if you guys want seats. It's really useful to remember that the stuff that you see teachers do is stuff that we generally spend quite a lot of time preparing. One of my deep learning courses basically takes me 6 months full time to prepare, so by the time you see it, hopefully I've got things working. 99% of the time, whatever I'm doing doesn't work. And so I found the biggest difference between people who are successful at things in general and those who aren't seems to be entirely about tenacity, which is both something I've anecdotally found and also seems to be something which some social science research finds as well, and particularly for machine learning. Machine learning you have to be super tenacious for, because it's something where when things don't work, they often don't work in kind of mysterious and hard to debug ways. It's not like kind of you're creating a web service or something and you need these specific steps to work, and then each step you get it to work and you check it off. Machine learning is not at all like that, and you kind of have to keep going regardless of you know, the fact that it didn't work. The second thing I think I hear more than anything else is, wow, I'm surprised at how fast you are at using your tools. So like, I'm super fast with the shell and with the editors I use and stuff like that. And again, that's something I've found a lot of people doing code-based stuff really well tend to be extremely familiar with all the keyboard shortcuts and all the little tricks, so that as soon as something pops out of their head, they can get it into their machine. So getting to know your editor and shell and stuff really well is a good idea. Okay, so so I think we'll go back to our non-greedy version of this, because that actually worked pretty well. So the last thing to do here would be to reformat this. And it's interesting, it's actually showed us, it's very clear now that actually somebody had an error, right? So another good reason to do your data munching very interactively is you can see mistakes. Shirley Austin must be a 5112 area code, so we can fix their mistake for them. So if now we want to reformat this in the format that was requested, we can just go ahead and we've actually already got the basics we need, which was \d\plus. So we'll capture that. And then \b\plus, and we'll capture that. \b+, capture that. And so we're going to go back, and then we're going to replace it with a slightly different format. Let's see. Start parenthesis end. Start parenthesis end. Oops. Start parenthesis end. There we go. So we can now send that off, and we finish doing our data munging. So yeah, question? For debugging regular expressions, yeah, the main trick is something that you, or one of the tricks is something I kind of did quickly earlier, which is I was trying to figure out why my caret 0 to 9 star wasn't working. So I got rid of a search and replace, and I just wanted to kind of take little pieces. So the first thing was, oh, maybe the inverse of a set operator is different in Vim. So I tried just, so slash means search in Vim. So I just said search for a non-0 to 9. And then I started hitting N, which means go to the next one. And I just made sure it seems to be going through the non-digits, right? And so then it's just a case of like checking each of your assumptions and then making your search smaller and smaller and smaller. Another thing is to do like less in each go. So I could have actually done the whole reformatting and finding straight from here, right? So once I could have put straight from here, I could have gone search for each group and replace. And I could have done it in one go rather than two, but like I kind of think splitting things up into multiple steps where you can see each step is a good idea. I think in general, debugging anything, the main trick is to, once something doesn't work, is to like find the smallest thing that doesn't work, and then find the, like, keep going back from there to find a small thing that does work. And now, once you know what the specific thing that doesn't work is, fixing it is normally pretty easy. One of the challenges with debugging in general is that if something in your code isn't working, it means that something that you thought worked in a particular way is not working in that way. So like you actually have to start with an understanding that you're wrong about something, which can be quite hard for people. So often, like one of the challenges I have with newer programmers is to say, okay, we're going to go right back to the start and create the simplest possible thing and then check every little step. And new programmers are often like, no, I already know this bit, I already know this bit, so we can jump to there. I think the problem is X. And debugging is never about, I think the problem is X. It's always about starting with, I don't know what the problem is because I made a mistake. And so you just like, requires a lot of humility. You go back, you check everything, and eventually, we've all had this feeling when you find the bug, oh, I'm an idiot. So don't wait to find out. I already know I'm an idiot, right? So let's just work on that assumption when we start debugging.
Okay, on that note, I think this video is just a masterpiece it's just a 20-minute, less than 20 minutes, but it's this piece of it, that is just an example of why Jeremy is so great. I mean, he shows us actually how his process is, how he works. And when you watch him, you can see that he's making errors, he's making mistakes. And you think, oh, Jeremy Howard making mistakes, but yeah, he makes mistakes, and then he goes back and fixes them, and he does this step by step. And it's a good way to work. I mean, some people, maybe they can do things right out of the box, and they've memorized the whole structure of regex in their minds, and they can just make flawless commands at a single, let them be who they are. There aren't very many of them. So the rest of us have to do it the hard way. And that's what Jeremy is showing us, is that if you're willing to do things the hard way and just make errors and go back and fix them, then you make a lot of progress. And I think we all can agree that Jeremy has made a lot of progress in his work. So here's the end state. He pulls out all the numbers and spits them out in the format that was requested. And that's what we would like to reproduce here. So what I tried was first thing I tried, which I didn't show you here, was I tried to download. I don't have Vim, and I've never used it. So I downloaded Vim for Windows, and I started trying to use it the way Jeremy is. And I quickly realized that you need to know stuff about Vim in order to use it. There's a set of commands and so on, and I don't know them. So I was stumbling around, and then I realized, no, I'm not going to do it in Vim. I'm going to do it in the Jupyter Notebook. We'll do the same process in the Jupyter Notebook. So, you know, I'm building this notebook and I'm going to push it to the repo after we're done. But the first thing you do is you download this. After you watch it, you download this data set that Jeremy has, and then this is a false step. Remember, I put it in a you know, in a pandas data frame, and then of course then we can get the answer right away because we just pull out the column of phone number. That's not what we want to do. We want to do this the hard way to learn how to use regex. So the next thing I did was I read the file in one big text string, and that's what we're going to start with. We've got the file read in, got a big text string, and we want to pull out all the phone numbers. So here's the blank part. We need to start processing this with regex commands, and this is the reason why we're doing this review, is because we went through it all before, and we might think, oh, now we know regex, but I, for one, have forgotten a lot of that. So I'm going to go back, pick up this notebook, just so we can remember some of the things out of it. The first thing that they did was they built, let's see, after the false starts that they did, they started using regex. So the first thing you have to do is to compile an expression that you think you're going to use. We've already imported regex in that notebook. This is how the format of that command looks. You compile some command that you want. So I'm just going to copy this and move over to our notebook. And then we'll edit this thing for what we want. And this is going to be I can just do so we're going to build a regex that extracts phone numbers. So we're going to build the string that we want, and this is the guts of the regex command. So we're going to get rid of this part and put in our own. Okay, so some of you probably know regex, having used it a lot in their work. I'm just learning it. So if you have an idea, let's just speak up and we'll try. I'm thinking that we want to find digits, and we want to find more than one of them. So I'm going to do this. I think I remember that from Jeremy's, right? He's matching digits, and then he wants to match a dash, and then digits again, as many as we can, and then another dash, and then digits again. So we could just start with this thing, which I think is going to do something similar to what we want. This is probably wrong, and we'll figure it out. But compile that command, and then I'm going to use this command to process the string. And I have to go back here to see how they do that. I think you just write the string and then dot. Let's see. She's not doing. Okay, let me just try that and see how it works. The string is called data, the string that we read. So let's see what this does.
Extract phone number.
Oh, yeah, extract phone number. Thank you. So string object has no extract phone number. Huh. Okay. So I've obviously. Yeah.
Wouldn't it be RE extract phone number and inside the parens data? So
okay. Let's try that. Let's try that. RE pattern is not callable.
I think we need to use RE match or RE search, something like that.
Yeah, RE search or RE find, something like RE, whatever you have compiled, dot search or dot find, I believe, would do it with data passed in.
Okay, so tell me again how I'm going to do this. I'm going to do RE match.
No, RE extract phone number, and then dot search or dot match, I forget, or dot find. To do search or find after the
Like
dot,
that?
and then pass in the data.
Oh, okay. Like that?
Yeah, or search.
Okay.
I don't recall.
All right, we'll try find and see if it worked.
Yeah.
No attribute find, so we'll do search.
We compile it, so now it's match or search.
Search. Okay,
Yeah.
so it's done one match. Okay, so
yeah, that's why it's find all, I think. For
okay,
finding everything.
so dot find all. Oh,
yeah.
RE.
Because search just gives you the first one.
Okay, search dot find all.
Sorry, no, dot find all, not search. Just dot find all.
Oh, okay, got it.
Instead of
Got
dot
it.
search.
Okay. Got it.
Oops, it's F.
Yep. Okay, let's try that. Wow, look at that. And okay, we have one thing that doesn't belong in there, but maybe that we missed it.
By the way, that was going to be my suggestion. Jeremy didn't do this, but in fact, it may be better to actually give 4Ds, 3Ds,
yes,
3D,
specify
3D.
exactly what we want.
Yeah.
But we don't want to miss numbers like this. So we could
Exactly,
do like we could say that we could have optionally a one dash, right? So in front of that, right? So we could say let's see, optionally is 0 or 1, right? So that's the question mark. And then we could go 1 dash, oops, 1 dash.
No, optionally is within brackets, I thought.
Oh, within brackets?
Meaning if you give two values which you wanted both values to be accepted, but if you're talking different options, then
isn't there a match that says 0 or 1, match 0 or 1 instances of this?
That's 0 or 1 instance.
I think it's the question mark, because that's what we want here. We want 0 or 1 instance of 1 dash in case we have a 1-800 number, right? So let's see what happens.
So I think one dash should be on inside a square brackets, and after that the question mark should be there for optional.
Oh, after that. Okay, like this. Is this what you were trying to say? Is this what you were trying to say? Okay.
Yeah,
like
I think something like that.
Like this. Okay.
I'm not sure, but.
Okay, but I think this is what Srinivas was trying to say, right?
Yep.
Okay, so let's try this. Oh, look at this one. We got this. We didn't really. Oh, and it didn't find the rest. Well, so 1 dash and then another dash and another dash. Maybe that 1-800 number was an error. Let me just let's just search for this guy. Well, there's 2 errors in our data here. We see this one here, and we see this one here. I want to just search for this among this in the string and see if it was actually a full number or if it was a mangled number. I'm going to go, let's see, I want to go in here and find, and then find that thing. Okay. Oh, no, it was a full number and we missed it. So, okay, let's see.
Because the format is different, yeah.
Yeah.
We had 2 hyphens, but the number has 3 hyphens in the data.
Yeah, that's right. But I put the 3rd hyphen here. Oh, that's because this asks for one or the other. So we want to get rid of this. Let's try that. You can see because the square brackets will only ask for will only trigger when you have a 1 or a minus. It only matches one thing. So
that's right.
Right. So
yes.
So let's try this and then see what happens.
But then this will require a 1 at the beginning for all, right?
Yeah, so it matched our 1-800 number fine, but but somehow it missed all the other. Okay.
Yeah, it missed the 5 because it starts with a 1.
Starts with a 1.
You made it start with a 1. The very first one is a must-have.
Yes, that's right. So I need to indicate that this is a group. So maybe like this, right? Then I'm requiring both, right? Should that work? Let's try it.
But it'll always also require that at the beginning.
No, because it's optionally. It's optional because of this question mark.
Okay. Let's try that.
So, okay. So, well, now we've added some problems. This is worse than before. Oh, it's matching. Oh, maybe this is groups. Okay, I see. These are the groups that it's returning.
Right.
I don't know why we're getting this second group of an empty set, but that's fine for now. Let's see. Everything looks good. In other words, we matched this. Here, I'm not sure there's a. Anyway, we did this. We still have a problem here, and I'm not sure why.
That one is missing. If I recall from the video, I watched it quite a while ago, but that one is missing actually the 5 in the file. You can go double check.
Okay. Let's look for it and show ourselves that that's the case. Find in page. Find that. Yep, it was no. Sorry. I want to go back up here and do that. I want to go back up to the top of the string and search for that. Yep, absolutely right, Srinivas. This was missing. So now what Srinivas said is we should require that we have 3 digits, and then we won't make that mistake, right? So let's. This part is right. It worked for us. There might be something we need to do, but here let's do what Srinivas said. Let's, instead of calling for any number of digits, let's call for 3 digits. Right? And let's see how that works. This was what Srinivas said at the beginning. So let's do that. Now we see that everything is fine. We didn't pick up the bad number. We did get our 800 number. We have a problem that we picked this up. We picked up an extra version. Because we've asked for the group. It's giving us back what we asked for, right? Because we asked for a group. We asked for a group that has a 1 and a minus in it. There's perhaps a better way to do that.
Joseph, one thought would be just eliminate the 1 and just leave it, because the 800 would then capture the 3 numbers instead of the 512. So you don't need the 1-800. You'll just get 800 dash something. So that's good enough.
Let's try that.
Just eliminate the dash, eliminate the whole thing, because it'll capture 3 figures starting with 800. Eliminate even the dash.
Okay, let's try that. I think there's going to be a problem, but let's see. Let's try that. Oh, that worked. Okay, so you're right. So now we've got all the numbers. We should perhaps return. Let's see. Now the problem is to select out, to reformat everything. So this is the main part of it. We've pulled out all the phone numbers. But the next part is we need to return those phone numbers in the format that was wanted. Remember, we want parentheses around the area code and we want no dashes. So I think that's where Vim has an advantage here, because Vim allows you to search and replace easily. I'm sure that regex does too. So somebody who knows more about regex than me, tell us what to do next. First thing I want to do is I want to find this first group of digits and replace it with itself bracketed by parens, right? So how do you do a search and replace in regex?
I think, okay, I not again super familiar. I have to search for it. But the thing is, first of all, I don't think you can do find all and replace all because it'll have to replace each one.
Oh, okay.
So that's the first part. And then there is a replace, I think, even in regex. So
yeah, I don't even think we need regex to do this. Let's see. Now we have the phone number list. We can work with it. We can use a string. We can use a string operation, I think. There's our list. And then we can do for n in phone for number. I'm going to just do some kind of a Python command. For number in phone number list, we want, let's see. Let's see. Well, maybe regex is easier. But I was thinking of just doing this by replacing the dashes. There's a string match command that allows you to.
you can
we
do an
try to
RE
split-
sub, RE.sub.
Yes, that's what we want.
That's the one.
And the first argument is the regular expression pattern. We have a new string in the second and a string to be processed in the third.
Okay, so
it's RE.sub.
RE.sub, okay. And then what goes in here?
The regular expression pattern that you...
the one that we already did here.
Right.
Okay, and then
the new string.
The new string that you want. Let's see. You mean the name of the output, or?
No. See, this is where you would have to capture each of the three after you have extracted. You have to generate. I believe there may be simpler ways, but you'll have to capture the 512, the 972, the 4942 individually from what we have captured. And then each of, and the new string would then be /1 space /2 space /3. Do you follow what I'm saying?
Yeah, but could we first just replace the, the dashes with blanks? Can we do that?
But excuse me, but it's the entire.
Okay, so this is our regular expression. I think there's a simple.
Yeah, see, the thing is, it is replacing the regular expression with what you provide in the second string. So
I
it's
see,
not.
I see. Right.
So, so you'll have to get it in that form.
In our regular expression, we can ask for groups, right? Yeah. We can do this. We can do this. I want a group with the 3 digits.
Right.
And then I want a second group with the second part of the number.
Right.
And then I want a third group with the last 4 digits. Let's see,
No, you have the brackets. Yeah.
Yeah. This thing, I don't like this editor in the Jupyter because it always it messes me up. It messes my bracketing up.
Yeah.
It always inserts brackets where I don't want them. So do I have this?
One more.
One more. Okay.
I think.
Yeah. Yes. I
Well,
think
right. No, the one more will give you the entire. Yeah, you'll need it, but it might group the whole thing, or not. Well, maybe not. We'll see.
Yeah, because this thing isn't part of the regex command. This part isn't. This is just enclosing the string that you want, and this is the last. And this is the yeah. So this is going to do what we want. I think. Let's see what happens. oops, that did not work. All right. Oh, but let's see.
Get rid of the additional brackets and see.
Yeah. Okay. Oh, yeah. Let's go back to what we had first, just to make sure that it worked, that it still works. So we're basically doing what Jeremy said. Just try stuff, and and figure out something that works, and backtrack. And okay. So this up. So something went wrong.
The bracket after the R.
Oh, we didn't need it.
Yeah.
Oh, okay. That's just that's right. I'm sorry. I don't know how I convinced myself that we needed that. So this is the command, regex. There it is. Now we're back. Okay. So now we want to get the first three numbers in a group, the second three numbers in a group, and the last four numbers in a group. And there's a way to get these groups back. So I think this is going to give us what we want. Yeah. So, oh, well, now we've got the groups as as separate strings. So
you could even just do a dot join in Python and join those with spaces.
Yeah, that's right. That's absolutely right. So we can do this.
So you could do a regular
phone number list dot join.
List comprehension for each with joining it.
Yeah, or we could. Yeah, that's right. Each one of these. So for number in phone number list, let's see. Number dot join with a space. Is that going to work? Number.
Actually, I would reverse it, like number dot join or dot join space item for item in
dot
blah blah blah.
Okay, so join dot. So sorry, it goes like this. It goes like that. Dot join number.
Actually, it would have to be each of the three within that, within the tuple, right?
That's right. And then we have this, it's a tuple, and so we have to, each tuple is going to give us one. And so if I were to ask, let's just play with this for a sec. If I were to ask from this phone number list, if I were to ask for the first one, the first element should be a tuple. Yeah, and so what we want to do is for each number, we want to join all the pieces like that, and then, in other words, we want to join all three of these pieces. So
yeah, so it would be something like space dot join tuple 0, tuple 1, tuple 2.
Yeah.
In tuple something for tuple in number list.
So join number. Join number.
No, join tuple 0, tuple 1, tuple 2 for tuple in
number list. Dot join. Yeah, I see what you're saying. Dot join tuple. This is perhaps not the best way, but it'll work. Join tuple 0, tuple.
I don't think.
Yes.
I don't think we need to do that. The tuple should be joined as is. The join function connects all the iterables itself. We don't need to.
Let's try that first.
You just say tuple. Yeah, he's right. I think
that would be very Pythonic if that worked. That would be great. So let's see if that works.
But wouldn't you have to reverse it, meaning put dot join tuple in the beginning and then?
Let's see. So we have the phone number list.
I think joint tuple should be at the beginning.
Yeah, that's what I was saying too.
Okay, I see what you're saying. Join.
No, the whole thing, the whole string include. Yeah,
that's it. That's right. That's the list concatenation thing, or the list comprehension thing.
Yeah,
absolutely. Thank you for that. So here we are. Let's try that. And that is exactly what we wanted, right?
Yeah.
So we're done. We didn't do it exactly the way Jeremy did, but we accomplished the task as assigned. So with everybody's help, we got this done. So I'm going to clean this up and push it to the repo if anybody wanted to try it and play with it and so on, right? And we actually even did it before 9:30. So if there's any questions or conversation that anybody has wants to bring up. How about have you heard about the new class, the FastAI version 4, course 1 version 4? You know that's being offered in April, right? And you also know, you might not know this because it's by invitation only. But here's the thing. I asked Jeremy if we could offer it, if we could offer the people in the TWiML group if we could lead a study group for the people in TWiML, and if they would then let them access the videos. And Jeremy said, he put out a note to everybody that yes, this is now going to be offered. So he's going to allow people in TWiML who are joining up for our study group. He's going to allow us to make a study group and allow these people to listen, that is you, to listen to the videos. He will not allow you to participate in the FastAI forum, but that's okay because we have our own forum on Slack. It's not as good as the FastAI forum, obviously, but if you have questions and so on, we'll have people on Slack that can help you answer them. So I'm in the process of organizing a study group for the second FastAI, for the FastAI version 4, which is going to introduce the FastAI. The cool thing about this course is it's going to introduce the FastAI version 2 library. And this is the upcoming book that Jeremy is writing with Sylvain, and they've already published a paper on arXiv, a paper about FastAI version 2 library. So this is going to be great. I'm organizing this class. The only problem is I got to find a time slot. And as you saw from our schedule earlier, we're going to be busy till the end of April with this class. We're not going to finish till the end of April. So we got to find another time slot that might work for us. And so let's start thinking about that. One possibility is the 7 o'clock time slot, 7 o'clock. No, 7 o'clock won't work because we only have till 8. We start at 8. One possibility is we could do 7 o'clock to 8:30, and then 8:30 to 10 for this class. We could shift it from 8:30 instead of from 8 to 9:30. We could shift it 8:30 to 10. That's a possibility. So start thinking about that, and whether you want to participate. You'll see more announcements coming out on TWiML about this class as we organize it. So what do you think? Is there some interest in this, taking the FastAI version 4 course?
I am in with a study group for sure, speaking for myself, but a quick question. How can we get in as one of the invited participants in Jeremy Howard's class itself? Is that the one where we have to apply and pay $2,000 through the University of University of San Francisco?
Yeah, University of San Francisco. So one way to take the class is actually go there and take the class and pay the $2,000. The other way is to be invited. And the way that Jeremy has his own algorithm for how he determines who gets invited. But part of it I just know that part of it is based on participation in the forum, in the FastAI forum. How often are you participating in the forum, and are you giving back something to the community? Are you publishing blogs and stuff like that? And he's looking at forum participation, and he has his own algorithm from there. But he's basically starting by looking at your forum participation.
And what if you've never participated in a forum?
Well, then if you want to be considered for future, when he, because he's obviously going to have a Fast AI version 2, the thing to do is to start participating in the forum and, asking questions, answering questions, and making your presence known in the forum.
Cool.
Yeah. All right. So any other comments or questions? Okay, well, thank you all for participating. I think we illustrated how to implement Jeremy's process. And I really like what he said is that, to make progress, I got my notes here, I took his notes. He said that the thing that distinguishes people that succeed from people that try something and then they end up stopping is, he said, it's entirely about tenacity. And so in other words, you just keep trying something. You be willing to do that hard work and keep trying until you get it right. And I think that's what we did today with everybody's help. Find the smallest thing that doesn't work and then go back and, in other words, instead of trying to do all in one go, one big giant command that you think is going to work, break it down into parts and find where it breaks and then go from there. And to do that, you have to have this attitude that I'm an idiot when you start. You just start out by thinking, I don't know what the hell I'm doing, so I'm willing to see, I'm willing to look at things carefully and go through each step carefully and figure out where I failed. I think that's a really important lesson that you can learn from watching Jeremy work. And we did it today, so thank you all. Let me just check quickly the comments, see if anybody, let's see, Mosh gave some links. Yeah, tenacity and humility, that's exactly right. So I'll post these, this chat on our Slack group. And I'm here till 9:30 if anybody wants to talk or make any comments or whatever. Doubts, raise some doubts.
I got to make time to do all this myself. Does everybody, have you guys talked about last week, perhaps when you did transfer learning, how so much of the business of artificial intelligence, and I work in this space and I call it AI only this year because we've come close to that now, but the business—
You mean in NLP?
More than just NLP, just commercializing machine learning frameworks and methods into business processes. It's a lot easier to just, rather than giving qualifiers to say machine learning this or so on and so forth, most people don't understand that. Most people will never understand that. And those who really run the world, control the purse strings and the financing and funding and so on, they don't even want to hear that. So you just call it AI, and most of AI businesses are nothing more than just transfer learning. You even said it, NLP. The big platform players like Microsoft, Google, Amazon with AWS and everything they have, they build, and commercial companies like Algorithmia and such, their whole business model is get the best data they can get, build models, make the models available via an API, which is ultimately transfer learning, that other businesses can then weave into their business process any way they want. Any thoughts on that, reactions, or that's not how you guys see it?
I think that, the interesting thing is that Sam is offering this class on building, on productionizing models. I think it's called enterprise, what is it called? Enterprise AI workflow in the enterprise or something like that. And Sam has his finger on this, on the pulse of how these things work. That's what companies are all doing now. They're building frameworks for doing the AI in an end-to-end process and then making it available to the public. So, start with your data set, do all the data munging, build your model, test the model, get the output, get the prediction, and then productionize it, and then sell it to somebody, or in that complete format that they could reproduce it in their own in their own workplace. And that's the big thing now. I mean, we're tinkerers. We're doing this in our garages, you know, building models and playing with things. But the big players they need more than just a one-off thing. They need more than just a pilot project. They need something that can be scaled up and done, you know, by huge numbers of people at the same time. Is that what you're talking about?
That is exactly what I'm talking about, and that is exactly what I'm doing. And so our focus is from the starting at many hundreds of millions to several billions in a year in annual revenues is what we've set it up. And yeah, we've built it. Now let's get the customers, you know, if you build it, they will come kind of.
But there's a battle now, right? Because it's going to be a battle to find out which company's process is going to win. You know, because every company, Facebook, Amazon, everybody, they're going to have their own way of doing things, and the one that is the best is going to win this competition. Or maybe they'll survive several different flavors of several different variants. One will be suitable for one kind of business, one will be suitable for another kind of business. But that's what's happening now, is they're battling it out. The battle of the frameworks, which one's going to develop the most attractive framework and get most people to come to it.